Tick the statements which are correct. For every triangle and two circles, there are 3 squares. So, for every triangle and 2 circles, there are 3 squares. For every triangle, there are 3 squares. 1 triangle, 1, 2, 3, 1 triangle, 1, 2, 3. And for every 2 circles, it's the same. That would be correct. For every triangle, there are 2 squares. That's definitely not correct. We've just checked that one. For every 2 circles, there will be 1 triangle. For every 2 circles, there will be 1 triangle. For every 2 circles, there will be 1 triangle. For every 2 circles, there will be 1 triangle. So that is correct. True or false? For every triangle, there are 2 circles. So we know we've got 6 triangles. And we know that there are 2, 4, 6, 8, 10, 12 circles. So we want to make it so that we know for every 1 triangle there are 2 circles, if that's correct or not. So if we divide this side by 6, we end up with 1 triangle. And if we do the same, divide this side by 6, we end up with 2. So for every 1 triangle, there are 2 circles. So that is true. Fill in the missing numbers. There are 2 triangles for every 8 squares. If there is 1 triangle, there will be how many squares? So there's 2 here and there's 8 squares. So if we're simply going to be halving that to make 1 triangle, we want to do the same on with the other shape. So we're going to halve this. Half of 8 is 4, so if there's 1 triangle, there will be 4 squares. You can write this out like this also: 2 triangles and squares. 2, 2, 8, and if we halve it, we've got 1 to 4. Harrison and Tobias are looking at the relationship between strawberries and lemons. Harrison thinks that if there was 1 strawberry, there would be 2 lemons. Tobias thinks that if there was 1 strawberry, there would be 3 lemons. Who is correct, and explain how you know. So again, similarly, we've got to add up the number of strawberries and lemons. So we've got 3 strawberries and 3, 9, there's 9 lemons. So we've got strawberries, just bringing back the ratio symbol here, which I have spoken to you about earlier, year 6, earlier in the year. You don't have to use the ratio symbol in these tasks. Actually, we're moving on to that a bit more tomorrow, but I'm just jotting it down so that you don't get confused. So strawberry to lemons is 3 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, just checking. And we're trying to prove, is Harrison right or Tobias right? So we want to isolate it down to 1 strawberry. So we're going to divide that by 3. So 1 strawberry. Let's find out how many lemons there would be. Divide by 3. So if we just had this 1 strawberry, we would have 3 lemons, 1 to 3. So it must be Tobias is right. And we know that because for every 1 strawberry there are 3 lemons. Complete the sentences using the images below. So we've got some sprouts and carrots. For every 3 sprouts, there are 4 carrots. And now it wants us to think about a fraction. Now, if you remember way back when we did ratio, we talked about how it links to fractions, but it's not the same. Because ratio, actually, you need to know how many total parts there are. So at the moment, we only know that there are 3 sprouts and 4 carrots. In total, there are 7 vegetables. So if we were thinking about a fraction, the denominator would be 7, because there are 7 in total. So we fill in our sevenths. And what fraction of the vegetables are sprouts? 3/7 of the vegetables are sprouts, and 4/7 of the vegetables are carrots. But with ratio, we don't actually write the total number of parts. It's invisible. So when I want to put my numbers into the ratio section, just below here, I will be writing 3:4. 3 sprouts to 4 carrots. And the part that's invisible over here is this 7, which is the total number of parts. So that is sprouts, and that is carrots, and that is total. But we don't tend to write this part over here. We just leave it out. It's invisible. Whereas in fractions, we always have the total number of parts down at the bottom, and how many of them are sprouts, for instance, at the top, total parts here, and how many are carrots at the top there. Use the image below to complete the ratio statements. For every 1 teacher, there are 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 pupils. For every 1 teacher, there are 10 pupils. Oh my, very small class. That would be interesting, wouldn't it? If there are 12 teachers, how many pupils will there be? Okay, so if there are going to be 12 teachers, so instead of 1 teacher, there's going to be 12. So 12 teachers. And so instead of 10 pupils, it will be 120. We want to multiply both sides by 12. Converting ratio is very, very similar to converting fractions. You want to do the same to both parts. There are 35 animals on a farm. For every 5 cows, there are 2 pigs. Use the bar model to help you calculate how many cows altogether and how many pigs altogether. Okay, so we've got a bar model already for us. There are 35 animals on a farm. For every 5 cows, there are 2 pigs. So this bar model, cow, 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 and that's pig, pig. So for every 5 cows, there are 2 pigs. How many cows will there be altogether? So we will know that this would be 5 cows and 2 pigs. So we've got cows to pigs is 5 to 2. But that only gives us a total of 7. And actually, the total number of animals isn't 7, it's 35. So what do we need to do? We have to make sure we do the same to all of the parts. So if we want to convert 7 to the correct total, we're actually going to be multiplying that by 5. So we'll have 35 animals on the farm, which just means we have to multiply both of these by 5 as well. So we are going to end up with 5 times 5 is 25, and 2 times 5 is 10. So there should be 25 cows altogether, and there should be 10. If you wanted to, you could draw a picture or a bar model to represent this further. You could just scale up this bar model and keep counting until you got to 35. So let me just show you that really briefly. So we've got 5 cows and 2 pigs. So you could draw it if you wanted to. 1, 2, 3, 4, 5. 1, 2. And this is the cows. apologies for not using a ruler, I'm just being quick here. Don't do this in your maths books. And then we would be making this, we'd keep adding more bars until we get to a total of 35. So this total would be 7. So then we can remember we can only add the same proportion again. So we've got 5 more here and 2 more here. 2 more pigs, that's adding another 7, so that will get us to a total of 14. And you could just keep going on and on and on until you get up to 35. But I'm just going to say, well, I've got another 5 and another 2, that's adding 7, so 21, another 5 and another 2, 28, another 5 and another 2, 35. And then we're finished. So then you would simply add up 5 here, and these 3, which gives us the total of 25 cows, and then 2, 2, 2, 2, 2, giving us a total of 10 pigs. What is the ratio of suns to rain clouds? So again, we've got 1, 2, 3, 4, 5 suns to 1, 2, 3 rain clouds. Use the ratio to calculate how many symbols there will be altogether if there are 20 suns. So it's the same principle here, we can actually just scale this up. So there's several ways of doing it. So if we've got, this is suns and this is rain clouds, I'm just going to jot this over here, suns to rain clouds, 5 to 3. We want to know how many symbols there will be all together if there are 20 suns. So to move this to 20, we have multiplied by 4. So we now need to do the same to the other parts. So we're going to do the same here, we'll multiply that by 4, which gives us 12. And then we can work out the total, this missing column here, the total, is going to be 20 add 12. So 20 add 12 gives us 32. So filling in these answers, we've got 12 rain clouds, and we have got 32 symbols altogether. So here's a worded problem. Mary is making buns for her birthday party but has limited ingredients. For every 3 chocolate buns, she makes 2 vanilla buns. For every 3 chocolate buns, she makes 2 vanilla buns. 3 to 2. Here's our clue that tells us this is a ratio problem for every. Okay. There are 66 people at the party, and 1/3 of the people want a vanilla bun. So 1/3 of 66. 1/3. To find 1/3, we're splitting into 3 equal parts. So 66 needs to be split into 3 equal parts, which we should be able to do in our head. 3's into 6 goes twice, 3's into 6 goes twice, so 22. So 22 of them want a vanilla bun. 22 want vanilla. So if we now add this 22 into our ratio section over on the left, so 22 will go under the vanilla column, 22. So what we need to now identify is what have we scaled up by. We've increased it 11 times, we've multiplied that by 11. 2 times 11 is 22. The really important thing to remember here is it's like fractions, we have to multiply or divide to keep the parts the same proportion. So we've got to do the same thing to the chocolate buns. So we will have 3 times 11 is 33. So how many chocolate buns will Mary make? Well, that is going to be 33. And how many people will not receive a bun? So chocolate buns, 33. How many people will not receive a bun? So we've got to think chocolate to vanilla. So 33 add 22 in total gives us how many will receive a bun, because they'll get a chocolate bun and a vanilla bun. Or they'll either get a chocolate bun or a vanilla bun. So that would be 55 get a bun, that the remaining 11 people will not receive a bun, because 66 take away 55 gives us 11. So there are my answers, 33 and 11. So today we're going to be thinking a little bit about scale factor. Scale factor is where you enlarge a shape by a certain proportion. So for instance, you might double the size of your shape. This is often used when you are looking at scale in things like maps or plans, bird's eye views, all sorts of different real life applications. So the shape below has been doubled in size. Select the shape's new dimensions. So the shape, the green shape is 4 and 3, so doubled would be A. Good. Okay. The shape on the grid has been enlarged by a scale factor of 2. Move the squares onto the grid to show the new shape. The first square has been placed for you. So if you want to, you can pause the video here and sketch the new shape in your book. I'm just going to start by dragging the boxes across. So that's double the height, and then instead of 2 along, it's going to be 4 along, and then it needs to be thicker as well, so we need to make it 2 high, and this part will be 2 wide. A scale factor of 2 means doubled. Every proportion would be doubled. Good, you got that right. Okay. Shiraz has been enlarging a shape by scale factor 3, and he says I need to double the length of each side of my shape. Well, so that's false, isn't it? Because if you double each side, you're enlarging it by scale factor 2. So that's incorrect, so it's false. Enlarge this shape by a scale factor of 3. So this means that we have to make the shape 3 times bigger. We're scaling it up by 3 times. So we're going to take each dimension, 7.4 centimetres and 12.2 centimetres, and we're going to multiply them by 3. So that's just using column multiplication. So if you give that a go in your book, and then we will mark the answers together in a moment. So I've shown 2 different methods here. To do 12.2 multiplied by 3, I've broken that into 12 times 3 is 36, 0.2 times 3 is 0.2, 0.4, 0.6, and then add the 2 together, it gives me 36.6 centimetres. And then I've shown column method below, so 7.4 times 3, we don't need to worry about lining up the digits, it's one of the only exceptions. 4 times 3 is 12, 7 times 3 is 21, add the 1 is 22, and we then use estimation. We know 7 times 3, roughly 7 times 3 is 21, so the answer would be 22.2 centimetres.
Tommy says, a scale factor of 2 means you multiply each side of the original shape by 4. Is he correct? We'll pause the video here and discuss whether you think Tommy is correct. Tommy is incorrect. A scale factor of 2 means you multiply each side by 2. We're making it double the size, 2 times bigger.
This shape has been enlarged by a scale factor of 3. Find the perimeter of the original shape. So perimeter going around the outside. So this is the new shape. So the new shape's dimensions are 6.6 for its width and 7.2 for its length, both in centimetres. So this is the new shape. It's been made 3 times bigger. So the original shape, the original width, would actually be 3 times smaller than 6.6. So the width, 3 of them, width times 3 would give me 6.6. So I've taken my width and I have multiplied it by 3 and I have got the answer 6.6. So how can I go backwards? What will I do? I will use the inverse. I will divide it by 3. So we will use a bus stop, short division, 6.6 divided by 3. How many 3's go into 6? 2. How many 3's go into 0.6? There we go. We've got 2.2 would be the original dimension of this side. 2.2 centimetres is the original. And in the same way, I'm not going to finish the bar model, but we need to divide this by 3 also. 7.2 divided by 3. 3's into 7 goes twice, remainder 1. 3's into 12 goes 4. So that would be 2.4 centimetres. So we'll have, let me just start a new slide. We'll have 2.2, add 2.2, add 2.4, add 2.4. 2.2, add 2.2, add 2.4, add 2.4. 2, 2, add 8, 12, 2, 4, 6, 8, 9. So the answer is 9.2 centimetres was the original perimeter.